So today we're going to start our new topic. This is on quadratics. I was a little ambitious in first period, so I'm still adjusting to what can I cover in 45 minutes or what will make sense in 45 minutes. So my original assignment I'm going to have to change a little bit. But here's kind of the plan. We're going to talk about graphing a quadratic today, and probably will have to spill over into Monday, and then the rest of next week is all about factoring. That's a very important skill that I need to make sure you've mastered before we move on. But that being said, let's talk about a parabola. Let's talk about graphing a quadratic, and there's like 3 different forms we're going to talk about hopefully today, at least 2. But let's talk about a picture. Anyway, so when you graph a quadratic, that picture is going to look like a parabola. And a parabola, well, that's our U-looking thing. You get 2 versions of it. Either it's turning up or it's turning down. We're going to talk about the parts of a parabola with it turning up, and then we'll talk about what happens when what makes it flip. You really can't just talk about a parabola unless you've got coordinate plane. So I'm going to draw my coordinate plane and finish the parabola. And actually, here's our little grid. And here's my parabola. And now let's talk about the parts. And you may already know about these from Algebra 1 class. But the most important part of a parabola is this guy. This is your vertex. If your graph is turning up, your vertex is the lowest point. If your graph is turning down, your vertex is your highest point. Pretty much everything you ever need to know about a parabola, the first thing you always need to know is the vertex. So we have our vertex. Some textbooks make a big deal about this. Honestly, I don't think it's that big of a deal, but since the textbooks make a big deal about it, and everything else, I need to talk about it. And that's called your axis of symmetry. Your axis of symmetry it's that line that cuts it exactly in half. As far as if I'm going to draw that line that cuts it exactly in half goes, wow. Draw straight. It's that line that goes through the vertex. And if it goes through your vertex, if I could draw better, then what's on the left is the exact same. It's an exact copy of what's on the right. It's called your axis of symmetry. So I'm going to make you identify it, although in the big picture of things, it's not super important. Other things that are important, and we'll talk about those today, are these dots. Because this is the x-axis, these dots are called the x-intercepts. And this dot is called your y-intercept. And math people aren't super creative because these are called the x-intercepts because it crosses the x-axis, and this is called the y-intercept because it crosses the y-axis. When we start doing word problems with parabolas, you're going to hear something about the maximum value and the minimum value. If the graph is turning up, this has a minimum value. There is a lowest point. If the graph is turning down, there is a maximum value or there is a highest point. So here's what we're going to pause for about 5 minutes. All right, so I talked about the graph. We have different parts. Now let's look at some algebra behind all of this. So we need to start with an equation. And our equation is going to be, write it over here, y is equal to x squared. Now, while you already may know what this looks like, and you had to do a ton of these in Algebra 1, anytime I introduce a new function, and I always claim that I don't know what it looks like, that's what I'm going to look at this. So if I see y equals x squared, I want to know what this looks like. Anytime you want to know what a particular function looks like, make an xy chart. So when I make my xy chart, I get to pick any values I want to for x. And the values I want to pick for x are, I like -2, -1, 0, 1, 2. So now when I plug this in, plug -2 into x squared, x squared I get a 4. Plug -1, 1 squared is 1, 0 squared is 0, then I get a 1 and a 4. And now I'm going to start plotting my points. So at -2 I'm at 4, at -1 I'm at 1, at 0 I'm at 0, at 1 I'm at 1, at 2 I'm at 4. And the thing about a parabola is once you get the dots on the left, you get the same kind of dots on the right, and now if I sort of connect my dots, I end up with this lovely U shape. All right. And there's our parabola. Great. So now we're going to do things to this graph. The things we're going to do to this graph, we're going to move it around. So the way I talk about moving the graph around is I ask, what does the 2 do? Oh, I'm going to start with y is equal to x squared plus 2. And so when I see y equals x squared plus 2, I want to know what the 2 does. Well, I don't know. So I'm going to make an xy chart. Pick my favorite values for x. So I'll pick -2, -1, 0, 1, 2. And when I plug -2 in, -2 squared is 4, 4 plus 2 is 6, -1 squared is 1 plus 2 is 3, 0 plus 2 is 2, 1 plus 2 is 3, 2 squared is 4 plus 2 is 6. So now I can plot my dots. So at -2 I'm at 6, at -1 I'm at 3, 0 I'm at 2, at 1 I'm at 3, and at 2 I'm at 6. And I'm going to draw my little U, my lovely little parabola. And things I want you to notice about this is that the shape didn't change. It's still a U. Still looks about like this. The only thing that happened is it moved up 2. Well, of course it moved up 2. I mean, if you compare this xy chart to this xy chart, the x's were exactly the same. The only thing that's different is your y values. I added 2 to all the y values. Well, if you add 2 to all the y values, you're literally saying take this point, shift it up 2, this point, shift it up 2, this point, shift it up 2. So if you see a +2 on the outside, that says you shift up 2. If that had been a -3, that means we take our parabola and we're going to move it down 3. So this number on the outside impacts things on the y, so it impacts things up and down. Next up, what if I give you y is equal to x minus 2. I'm going to run out of room is the problem. X minus 2 squared. So now instead of having a +2 on the outside, I have this 2 inside the parentheses. So I'd like to know what happens. And I don't know. So I'll make an XY chart. I am going to modify the x values because I mean that's the reason you use an XY chart. Like ideally you like to use -2, -1, 0, 1, 2. Those are the easy ones to use. But the reason you use an XY chart is you can pick anything you want to for x. So I'm going to pick 4, 3, 2, 1, and 0. Just because I'm crazy, but I somehow I think my y values are going to be nicer if I pick these. So let's see what happens. If I plug a 4 in, I get 4 minus 2, and that's going to give me 2. 2 squared gives me 4. 3 minus 2 is 1. 1 squared is 1. 2 minus 2 is 0. 0 squared is 0. 1 minus 2 is -1. Squared gives me 1. 0 minus 2 is -2 squared gives you 4. Now when I plot these, let's see, it says at 4, I'm at 4. 1, 2, 3, 4. At 3, I'm at 1. At 2, I'm at 0. At 1, I'm at 1. And at 0, I'm at 4. And now I'm going to connect the dots to create my lovely looking U thing. All right. Now if I ask what happened, what did this 2 do? Well, it took my parabola and it shifted 2 to the right. Now, usually people, it's pretty easy to remember, okay, I put a plus or minus something on the outside, that's going to take the graph and shift it up or down. I tend to get mistakes with things inside of parentheses, and you may have been told if it's inside, it's backwards. That's typically what I've done. The reason is, and this is something I'm going to reference later in the year because it's going to keep showing up, anytime you see something in parentheses, you take that something and set it equal to 0. So if I take that x minus 2 and I set it equal to 0, when I solve, I find out x equals 2. It ends up, that's why effectively you're just doing backwards, but you think what makes this 0 a 2, and so it shifts to the right 2. So to summarize this, and if you already know how to do this and you can do it in your head, great. I just want you to do a rough sketch of this, okay? Because I want to point to some things. If I give you y is equal to x minus 3 squared plus 1, I want everyone to do a rough sketch of this. I don't want you to plot points. What I want you to do is you've got a parabola. So our parabola starts off here. That plus 1 says we're going to take our parabola and shift it up 1. And that minus 3, because it's opposite, right, it says I'm going to move it 3 to the right. And so I want everyone to draw a parabola. It doesn't have to be perfect, all right? I don't care if the shape's right or anything else. I just care that you take a parabola, and if you see x minus 3 squared plus 1, so I want you to draw that on your paper somewhere, computer or whatever. And once you've done that, do the electronic raise your hand. Okay. So combining these two ideas, here's your rules. So inside means you're moving left and right. Outside means you're moving up and down. So inside my parentheses, this is telling us I'm moving 3 left and right. That plus 1 on the outside means I'm moving 1 up and down. So my original parabola started here. And you don't have to plot these 5 dots. This parabola says, what I have in purple says, take this parabola, the plus 1 says, shift the parabola up 1. So this goes here. And this says shift the parabola 3 to the right. So I'm going to go 1, 2, 3, and put a dot. And now I'm going to create my lovely little parabola. And that gets our picture. Since I did not get the kind of participation I wanted, we're going to try it again. So I want everyone to graph y equals x plus 2 squared minus 3. So I want everyone to graph this somewhere. You don't have to plot a bunch of points. I basically just want the vertex in the right spot. And then once you've got that graphed on any scratch sheet of paper, then do the electronic raise your hand. Now we're graphing the brown one. Got more participation here. Now, so this one, That plus 2 says, okay, I need to move it to the left, right? Because inside the parenthesis, all right, I'll look down here. That minus 3 says take the original one, shift it down 3. This plus 2 says we're going to move it left and right. That minus 2, because it's inside, it's always backwards. So now this is going to go down 3, back 2. And now do the best you can to draw your U. I'll be a little more precise because I can be. And let's see. And I'm not asking you to plot a bunch of points. I'm just really all I care about right now is the vertex. Now,
So when you're adding, you move to the left.
yes. Anytime you're inside the parentheses, it's backwards. And there's going to be things we're going to do later of the sort of the glossing over answer is what makes this 0. Like you take what's in the parentheses and set it equal to 0. And when you set that equal to 0, it tells you I need to go to -2. All right. So the intent is that this should be, if I give you something, like I give you a different graph, if I give you y is equal to, okay, good, you can see that. If I gave you y is equal to x minus 4 squared minus 2, this would be very easy to graph. Right? Right? You're just like, okay, I see the x squared, I know I get a parabola, and I know what these numbers do, right? I can look at this and says, okay, well, I'm going to go down to the opposite of this. I'm going to go to the right 4, 1, 2, 4, and then I'm going to draw my dots. Now, the reason I wanted to do all of these things is, well, actually, so now let's talk about what we know about this. I don't know if you remember at the very beginning, I said the most important part of a parabola is the vertex. So, let's look at the purple. Your vertex. We go back to this purple line. Our vertex, and it looks like if I wanted to find my vertex, it's going to be at 1, 2, 3, 1. So this has a vertex at 3, 1. If I look at the brown, you may not be able to tell it's brown here, okay? If I look at the brown, here's my graph. And if I want to find the coordinates of the vertex of the brown, that's going to be -2, -3. And if I look at the orange, I go look at my orange, and that's my vertex. If I want to find the vertex of the orange, let's see, 1, 2, 3, 4, 2. So this is my vertex of the orange is going to be 4, -2.
Wait, which vertex was the -2, -3?
The brown one. I tried to write the vertex right under the individual equations.
Oh, okay.
Now, so the reason that I tried to write the vertex under the equations is there any would it be easy to pick out what the vertex is from here without graphing? Like, if I gave you, I'm going to give you a green function. We're not going to graph the green function. But if I said y equals x plus 3 squared minus 5. Well, that's hard to read. But if I gave you x plus 3 quantity squared minus 5, and I said, what is your vertex, would it be easy to identify the vertex without having to graph it?
Yes.
Yes. All right. What is my vertex in this?
-3, -5.
Perfect, right? So you just go through and say this is -3, -5. So if you get a quadratic function that looks like this, we like this. It even has a special name. This special name is called...
How did you solve the -3, -5?
What, how?
Yeah, how?
Well, so let's look at the purple one just for a second. So if this was the graph, this was the equation. Do you see how, if you look at this, this number, our vertex is going to be an x and a y part. if you look at all of these examples, the y part is this number sitting off to the side, and the x part is the opposite of this number. See?
Oh, okay.
The y part, right? So when it looks like this, it's very easy to identify the vertex. It's so easy to identify the vertex, they have a special name for it. Anytime it looks like this is called vertex form. And the reason it's called vertex form is it's very easy to identify the vertex. Right? You just look at it and say, oh, that's my vertex. Oh, I look at this. Oh, that's my vertex. Right? It's called vertex form. Now, one more thing we have to add to vertex form, and then we'll move on. And that one more thing we need to add to the vertex form is what happens. I'll have to erase. So here's my original one. This is just y equals x squared. I like having this base here. I have y equals x squared, so nothing's crazy. What does the graph of y equal 2x squared look like? What?
It looks thinner.
It looks thinner, right? Well, let's say you didn't know what that does. Like what happens when you have the 2? Well, if you don't know, you can just do an xy chart. So that's what I'm going to do. I'll make an x and a y, and I'll start plugging values in. -2, -1, 0, 1, 2. Then I'm going to do -2 squared, I get 4. 4 times 2 is 8. -1 squared is 1, times 2 is 2. 0 times 0, then I get a 2 and an 8. And let's see, at 1 I'm at 2. At 2 I'm way up here at 8. Then I'm at 2, and then here I'm way up at 8. Now if I draw this, so I still have a parabola, right? I still have a u, but there's a difference. Now, here's how I want you to think of this. So here, imagine you have a sheet of rubber. You ever actually imagine like you have a balloon? Have you ever seen something on a balloon? Like if you draw something on the balloon, and when you blow up the balloon, that whatever you drew on the balloon gets very distorted? Well, that's exactly what's happening here math-wise. What I've done is this black graph I put on a sheet of rubber. So here it is. And then this times 2 says take that sheet of rubber and stretch it twice as tall as it's stretch it twice as long. Well, if you do that, it's going to take your original parabola and stretch it up. The other way I've described this in the past, and I don't know if I'll fit in the picture, there was this medieval torture device called a rack. So to torture someone, they would strap them on them, and then they would like stretch them. So what I want you to imagine my arms are holding up a parabola, and I'm made of rubber, otherwise it gets really gross, and I'm on the rack, and they want to stretch me twice as tall. Well, if they stretch me twice as tall, what's going to happen is my arms are going to be pulled up. Right? They're going to be pulled up, and that's going to change the shape of my parabola. Yeah. Similar thing happens if I have like y is equal to 1/2 x squared. Now what's going to happen is that sheet of rubber gets squished to 1/2. So my arms, which started this way, now get squished, and so the parabola gets wider. So in general, whenever you have a number in front, that number changes the shape of the parabola. It either makes it really skinny or really fat, depending on if it's a number bigger than 1 or it's a fraction. The last thing I need to talk about is, well, what if it was a -1/2? Well, if it's a -1/2, what's going to happen is my parabola is going to get squished, but because it's negative, that negative on the outside flips it down. So I end up with a parabola that's down and fatter because it's been squished. All right? Now, so to put all of this together, if I said y is equal to, let's read that, negative, Actually wrote an example out. Negative 1/2 x minus 3 squared plus 8. So if I give you this lovely equation, now I'm going to ask you to graph it. Well, now there's good news and bad news. The good news is, well, you don't have to plot a lot of points because I'm asking you to do this in Khan Academy. Here's how Khan Academy wants you to graph. Some of you may have already looked ahead, that's fine. What Khan Academy does is it gives you basically this interactive grid, and they give you a parabola, and the parabola has 2 dots. You grab one dot and you put it to where the vertex is supposed to be, and then you have to find out where the other dot goes. So you have to give it 2 positions. One position is always going to be the vertex, and that's going to be pretty easy to find because that's an 8. Right? I need to write that with a marker that writes. I was trying to. Okay. So if I'm going to graph this, how I graph this is, well, first I've got to find my vertex. So to find my vertex, look, my vertex is, it's always this number, so it's an 8, and then the opposite of this, which is 3. So I get a vertex of 3, 8. 1, 2, 3, 8. Get a dot. It's negative, so I know my parabola should be turning down. And for Khan Academy purposes, I need to find another dot. Like how I've been graphing is, I graph 5 dots. You don't need to graph 5 dots. You need a vertex and one other dot. And how you find that other dot, you can plug something in. So I'm going to make a really small XY chart. I'm going to pick an X value. Now, you can pick any X value you want, and I want to talk about a useful X value. You could pick 0. 0 is always usually nice. But what you're going to find is your life's a lot easier if you pick an X value that's pretty close to the vertex. Now, as far as pretty close goes, if I'm sitting at 3, maybe I'd like to pick 2, but when I pick 2, the Y value doesn't turn out so nice, and that's not going to help you out in Khan Academy. See, if I plug a 2 in, let's see, 2 minus 3, that's negative 1 squared. So I get 1/2 times 1 plus 8, negative 1/2. So I get negative 1/2 plus 8, that gives me a positive 7.5. That's hard to plot in Khan Academy. Khan Academy likes nice whole numbers. And so when I try 2, I get a decimal for the Y value, and that's not very helpful. So 2 didn't work, so I'll move a little further away. I'm going to try 1. And when I try 1 minus 3 is negative 2. Negative 2 squared is 4 times 1/2 times negative 1/2 plus 8. So I get negative 2 plus 8. That gives me 6. So at negative 1, I go up to 6. Now I have my dot. Now, what I really like about Khan Academy at this stage is if you put this on if you put the vertex here and then slide one more dot here, then you get to see the whole parabola and you haven't had to plot a bunch of points, which is why I wanted to do the Khan Academy one. And it's also a way where you'll start seeing how some of these graph. All right, so I've got to do one more thing. I wanted to make sure I talked about talked about vertex form. In your textbook, they talk about vertex form looking like this, where they'll say y is equal to a, x minus h squared plus k, where your vertex is at h comma k. This gets intimidating because you got a bunch of variables. I tried to present this with numbers. For example, if this is h and k, right? If this is a 3 and an 8, we said our vertex was 3, 8. They're saying your vertex is h and k. They talk about A, like if A is positive, you get a happy face. If A is negative, you get a sad face. That's what happened here. And they talked about its, like the fractions make it steeper or fatter or whatever, skinnier or fatter. Now, there are 2 more assignments, and I've got about a little over 6 minutes to talk about them. And it's to introduce word problems, because we will be doing word problems with parabolas, and sometimes they can get tricky. So, like right now, everybody's done parabolas intro, but they also have the 2 assignments right after it are dealing with word problems. So here's how the word problems work. And I really like what they do. They give you a whole bunch of words that you could probably ignore, and they give you a picture. And so I'm going to draw a picture. And it's a parabola. It's a parabola either turning down or turning up. I'm going to draw it turning up because it's usually turning up. And I'll do this. All right. Now, there are certain questions they ask, and I want to make sure you understand how to answer them. Whenever they ask for how high or how low, one of these things, this is looking for a y value. Whenever they ask for when, that means they're looking for an x value. All right? Now, what does that mean, right? So, let's see, one typical example is, all right, this quadratic function's modeling somebody throwing a ball, or sometimes it dips or whatever. I mean, they have different words, but they have the same picture. And sometimes they ask, how high? Well, they'll ask either what's your maximum height or how high was it when you started. Well, if your maximum height, let's see if I look here, that's 4.7. So in this case, if I ask how high, well, I'm looking for a y value. So in this case, if I ask how high, that's just going to be 7, whatever units they happen to be at. If they ask when it achieves its max, when does it have a max? Well, that's going to be the x value, and so in that case, that's going to be 4. Sometimes they ask the initial height. And your initial height is the height at the beginning, and so you only look from x equals 0 to the right. So my initial height is whatever my y-intercept is, which in this case is going to be 3. And sometimes they ask how long, right? It's asking about time.
Is the initial y always going to be how the intercept? Or
Yes.
Is it always,
Yep. The initial height's always going to be the y-intercept. And sometimes they'll ask how long was the ball in the air. That's looking for time. I guess when I'll put in anything related to time is dealing with an x value. And so if I want to know how long it takes for the ball to hit the ground, it'll be this point, which is, what is that, 8, 0. So in this case, how long is going to equal 8 seconds or minutes or whatever they have on it. So here's what I need you to do. Your homework is not out of your textbook.